Hello and welcome. Today, we are going to talk about Hermitian matrices and why their conjugate transposes are the same as the matrices themselves. If you are not familiar with Hermitian matrices yet, do not worry. I will explain everything step by step. Let us begin by understanding what a Hermitian matrix is. A matrix is called Hermitian if it is equal to its conjugate transpose. Now, let me explain how to compute the conjugate transpose of a matrix. First, you take the transpose of the matrix. Taking the transpose means flipping the matrix over its main diagonal, so rows become columns and columns become rows. Next, you take the complex conjugate of each entry in the matrix. Taking the complex conjugate means replacing each entry with its counterpart where the imaginary part has the opposite sign. That is all you need to do to get the conjugate transpose. Now let's revisit the definition of Hermitian matrices. As we mentioned earlier, Hermitian matrices are matrices that are equal to their conjugate transpose. For this condition to hold, the diagonal elements h11 and h22 must be equal to their own conjugates. This implies that these diagonal elements must be real numbers because only real numbers remain unchanged under complex conjugation. Additionally, the condition h21 conjugate equals h12 tells us that the off-diagonal elements h21 and h12 must be complex conjugates of each other. If you found this video helpful, please like, share, and subscribe for more content on mathematics and data science. Thank you for watching.